write a piecewise defined function for this velocity curve. So that's an Algebra 1 question, but it's been a while. How do we write a piecewise curve? Okay. Nope, I can't move that. That'll still help. Okay, this first line, what's the equation for that first line? Y equals 2. Does everyone agree with that? From 0 to 3. It doesn't really matter where I put the underline. I can put it there or on the middle one. It's up to you. You've got options.
Did you do both?
No. You have to pick one. And we're going to do that middle section. That's the one that takes the most work. I'm going to do a side note. How do you write an equation for something that looks like that? Step 1, I need the slope, right? I've got 3 points. Pick 2 of them. 0 minus 2 over 5 minus 3. And so I get negative 2 over positive 2, which is negative 1. So slope's negative 1. And then I can use point slope form. Y minus 2 equals negative 1 times x minus 3. But I do want to get y by itself, right, so that I can write it in. So I get negative x plus 3 plus 2, so plus 5. So I had to do some side note there. 3, whoops. Since I didn't put an underline on the other one, I do need a filled in dot there. I'm going to do it both pieces here, but there is nothing incorrect about doing those underlines in a different location, since these connect and are filled in. And then the last one is the line y equals negative 2 from 7 to 10. Any questions about that? Piecewise defined function for acceleration. What's a quick way to make that happen? Take the derivative of each one. What's the derivative of 2? What's the derivative of negative x plus 5? And the derivative of negative 2. The one thing I'm going to be careful about is on these intervals, I am not going to put underlines. Why would I not do that? Someone tell me. Good. At a sharp corner, the slope does not exist, right? The derivative does not exist. You could put it on the endpoints. No one would argue with you if you put it on the endpoints, but on those middle two, those are definitely sharp corners, so the derivative at those values does not exist. Okay, so those two questions are old questions. One very, very old, and the second one first semester. This one asks a different question. It says, what was the net distance traveled, or the displacement from 0 to 5? So, what did I travel from 0 to 5? And anyone have any idea how we could do that? I just didn't hear you. What'd you say? Area. If I have a velocity curve, wouldn't distance be area? And we'll talk about displacement in a minute. It turns out from 0 to 5, it doesn't really matter what I call it. It's the same because I only have positive distance traveled. I'm going to find the area of that trapezoid, or you could do a rectangle and a triangle. It doesn't matter. And so we have, what is that? Just from 0 to 5. but we'll talk about that in a second. 9. Does that sound right to everyone? 1/2 base 1, which is 3 units. Base 2 is 5 units, so 8. Half of that's 4. 4, 8. I think it's 8. But I could be wrong too, so argue with me if I'm wrong, please. 8 what? Feet. So I've gone 8 feet in the first 5 seconds. What is the total distance traveled from 0 to 10? Okay, it doesn't ask for net distance or displacement. I want to talk about the difference in that. You track runners, you go run on the track, right? If you're running 2 miles, maybe you go 8 times, right? Does that mean you didn't go anywhere because you started where you stopped? No, you went 8 miles, right? So what that is called is your total distance traveled. Your displacement may be 0. You may have ended up at the same place you started, but your total distance traveled is 8 miles. So with that being said, total distance from 0 to 10, 16 feet. Because we're going to add in this area if I want total distance, right? What is the displacement from 0 to 10? 0 feet. Because the positive and negative area canceled out. And if we are talking about where I ended up in the same place I started. So we're going to be revisiting velocity, position, and acceleration. And we're going to be looking at some new concepts. Actually, old concepts. We did total distance and we did net distance when we did derivatives. We had to find position at a time and then a position at another. Y'all remember doing that? The little diagram with the mouse. Y'all remember the mouse? The little diagram with the mouse that was going back and forth? No? Yes, no, maybe. Turns out this is going to make that easier. Total distance traveled is the integral from A to B of the absolute value of the velocity curve. One thing I want to point out, common mistake, this is not the same as the absolute value of the integral. Okay, not the same. These are not equal. Because if you just absolute value the integral on that last problem, the absolute value of 0 is still 0. That doesn't give you total distance. You have to do the absolute value of the velocity curve, which actually gives you a thing called the speed curve. We'll talk about that later. And the speed curve, the area under speed is total distance traveled. Net distance is just the plain integral. If we want to find a location of where I am at, I have to take into account starting point. Remember, an integral just gives me the change in my distance or the change in my position. If I want to find actually where I am, then I have to take into account where I started, which is an initial condition. There are 2 ways that we will use the initial condition. One of them is we may find C. You know that plus C you've been putting on everything, and you're like, what is this? But okay, I'll put it because Ms. King says so. Well, we may go find that C using an initial condition. Much like in Algebra 1, when you went and found the y-intercept, you know what I mean by that? You plug in a point and go find the y-intercept. Same thing here, we can find the C. The other way we will use it is in a rearrangement of the fundamental theorem of calculus, and I'll show you that after you're finished writing.
this is different than like, the equation that we got in BC. Like the, I don't know, maybe is it because it's polar?
For total distance.
For alpha.
Yes. Well, the distance, this is the velocity curve. If you have a position curve or something, it's a little different on what curve you start on.
Which one did like the BC that be the square root?
That's the arc length of a function. So that gives you the length along the curve. And so if you're wanting the distance along the curve, then that's the formula you would use. This one is more if I'm given a velocity curve, how to find distance from that. If that makes sense. Okay. Let me talk about this formula. It is one you'll want to memorize because it's going to save you a lot of time, but it's nothing special. Would you agree you have this formula memorized? F of B minus F of A. Right. If you don't, then you need to work on that mastery exam. Right. Okay. If I added the F of A over, could I find F of B? That's what the formula is. Say I want to find where I am at 3, but I know where I am at 2. Well, I can do f of 2 plus the integral from 2 to 3 of the derivative, and you can get that other y value. So it's a very quick way to get y values. This also works if the start and end point are backwards. So say you're at 4, but you want to find the value at 2. It's okay. Just make sure these go backwards because you're undoing accumulation. You're going backwards on, so that's okay. It still works. Okay, so example 1. Particle moves along the x-axis at any time t greater than 0. Its velocity is given by this function. The total distance traveled by the particle from time 0 to time 2 is. Now, the first question I'm going to ask, is this a calculator problem or not? It is. That's nice. If this is a calculator problem to do total distance, I just use a formula. Your calculator will deal with that absolute value quite well. Without a calculator, it becomes a little more complicated, and we'll talk about that in a second. Everyone know how to type that in? Do that for me. Alpha window F int.
Is there anything like indefinite on this kind of figure?
No.
So if you could do it
You can't. So that calculator is not capable of doing an indefinite integral.
Oh, I have a question. Back yesterday, it was like there was, you had to take the derivative or the integral of cosine x squared, but it was x squared that was.
That was squared.
So is that a substitution one where you plug in u? Or?
If there's something outside it, yes. If not, it's one that you'll use a calculator on.
Like, and I didn't, the calculator wasn't giving me it. Like it said, it won't, you can't do it.
No, but you could do a definite. Was it something where you needed?
No, it was just an indefinite.
You'll have to show me. But it's one that you can't do.
It's like two questions in a row. It was like just like sine t of 2/3 or something like that.
Now, if it had an x sitting out to the side, it's yeah. You'll have to show me. What do we get? C? Okay, next question. Suppose the acceleration of the particle is given by this, and v of 1 is 0, and s of 0 is 8. Find the position s of t of the particle. So I want a function s of t for position. I have acceleration. Now this sounds like a problem we did in the fall, almost, right? Except which way did we go in the fall? The other way. We had position, and we took derivatives to find acceleration. Yeah, go backwards. So, to find velocity, if I have acceleration, velocity would be t cubed plus 2t squared plus c. Why plus c? Because I told you to. Why do I keep telling you to put plus c? Couldn't there be a constant when I took the derivative and it would go away? I actually now need to find c. Look at this. At 1, the velocity is 0. Does everyone see that? So what I'm going to do is put 0 in for the velocity and 1 in for t. And find c. So what is this? So c is 0. But could it have been something else?
Are you trying to find c?
Well, I want to find s of t, but first, before I can find position, don't I need velocity? Well, and what is c? I would want to know that, right? So now we're getting to use c. You've wondered what c was. So on this one, c was just 0, so this is the actual velocity curve. No more plus c because c was 0. So then what is the position curve?
It would be 1/4 t4 plus 2/3 t to the 3 minus.
Are we taking the AT?
Uh-huh.
I thought we had to minus that AT to get the BT.
We did.
Other antiderivative of that?
Why would we do that?
I don't know.
Minus 3/2 t squared. Plus c.
Okay, so remember back to the fall, right? We would have the position curve and we'd take the derivative to get velocity and then we'd take derivative to get acceleration. We are going backwards. What's the last thing I probably want to find?
C.
C. How do you know it's 8? Okay, I plug in 0 for t, s of t is 8, all the t's go away, and so I just get c is 8. So s of t.
Why do you need to part that one out?
Because I want s of t, the real s of t function.
AP.
Which is 1/4 t to the 4th plus 2/3 t cubed minus 3/2 t squared plus 8 is s of t. We will finish. It's kind of strange. We will finish these notes tomorrow. You are welcome to get started on your homework. Okay. The Monday's probably wrong. That's from last year. But it is not tomorrow. It is not due tomorrow. Nothing is due tomorrow. Well, we'll see. Not tomorrow. Let me see how far we get tomorrow. Maybe Friday. Okay, so AP packet, you're going to do 2, 4, 12 through 16. I'm going to do 1 and 3 in class tomorrow. You saw that on the notes. I'm going to do 1 and 3, so you can wait on those if you want. I am not quite finished teaching, but you kind of got the gist. You can start picking at it if you want. Page 390 is another assignment in addition to the AP packet. So, again, no official due date on that yet, but start picking around at it. Tomorrow we'll finish the notes from today. Any questions? So, essentially, the first part of Unit 6 is we're going to do velocity, position, acceleration again, backwards.